What keeps a square from moving? Square roots. And we'll be using a few square roots today, primarily in the distance part of our lesson, but you've already done some of this in 8th grade, so this shouldn't be too hard. So first of all, let's go ahead and revisit the idea of a midpoint. You actually heard of midpoints in 6th grade and maybe even 5th grade. But they were a little more complicated. Back then, it was just like, okay, in the middle. Now we're going to go ahead and use these with coordinates. So I've got two coordinates here, 2, 3, and 8, 7. So if I were looking for the midpoint, it would be somewhere halfway between on the line connecting them. One way to look at that is to look at how far across and how far up and down I would need to go. Then I could just go halfway across and halfway up and down. You can see I came 3 across here and 2 up. And this would be my point, which looks like it would be about 5, and adding 2 to the 3, 5, 5. Now, another way to look at a midpoint is to think that it is an average. So those of you doing the fill-in-the-blank notes, average of the 2 points. So let's take an average. If you remember when we grade tests, if you have an 80 and 100, the average would be a 90. The way we average grades is we add them up and divide by how many there are. For midpoints, there are only 2 points, so you're always going to be dividing by 2. 2 plus 8 over 2, so that would be 10 over 2. 3 plus 7 over 2 would also be 10 over 2. And then simplifying, I get a midpoint of 5, 5. So this is really where your formula for midpoint comes from. You can see it in your math chart, and it looks a lot like this right here. I'm not real fond of this formula only because it's not really an equation. So in our examples, we're going to write this in equation form, where this is x midpoint and that is the y midpoint. Now, you also have this part from your book, and it shows you, okay, here's your x1 and your y1 down here. Here's your x2 and your y2. And then you average them to get the midpoint. See how they say the word average. Now, finding coordinates in midpoint problems. If we were just always finding the midpoint, it would be pretty simple. Just add them up and divide by 2. The problem is when I give you a midpoint and an endpoint, and then ask for the other endpoint. So the best way to solve these is to first label your known values. Know what x1 and y1 and x2 and y2. And if you know the midpoint, what xm and ym is. Do not mix up the endpoints and the midpoints. Those are two different things. Midpoints are in the middle, endpoints are in the end. Then what we're going to do is we're going to use these equations, which all I did was take the same thing from your math chart and put xm in front for the x coordinates and ym in front for the y coordinates. So we're going to set up these equations and solve, and you can always check by graphing. So for example 1, I want to find the coordinates of the midpoint of PQ, segment PQ. It really should have a line over it. With endpoints, I don't like that. Printer, there we go. Let's put a little line over our segment. Naughty book. Maybe it dropped it when I copied. So this segment has endpoints -8, 3 and -2, 7. So we are going to take the average of the x's and the average of the y's. First of all, I'm going to go ahead and draw a graph, and you can start by graphing if you want to, but actually the better thing to do is to start by labeling. So what I did is I labeled x1 and y1 and x2 and y2. You can label it right in the problem. Then I wrote down our new formulas for the midpoint. Now I'm going to substitute and put in the -8 in for x. Notice how the x's, let me go ahead and highlight these for you. Notice how the x's are first. So I'm going to use the first value from each coordinate pair for this first equation. So -8 and -2 go in here. And then, let me change the ink color here. 3 and 7 go together. So I'm going to add those two to get the midpoint. So I've got the x midpoint is -8 plus -2 all over 2. And the y midpoint is 3 plus 7 all over 2. And this simplifies pretty easily. I'll find that the x midpoint is -5 and the y midpoint is 5. or the coordinates are -5, 5, which are right here, and that does match what we have on our graph. In our next example, this is more typical of the rigor you're going to find in your problems. Here we're giving you the x coordinates, so there's your x1 and your y1. Let me get my highlighter here. So here's an x, and here's an x. So these 2 points are going together. And then the 2 y points are going to go together. And I'll just do orange here. So the 7 and the 1 will go together. But notice that this is a midpoint. That is not an endpoint. So it's not going to be over on the same side. So when I write down my formulas, here's x sub m equals x1 plus x2 all over 2. Y sub m, and we say sub, that means subscript, equals y sub 1 plus y sub 2 all over 2. Substituting, you can see I pull in the 6 from over here down to 6. So the 6 goes from here to the midpoint side. The 2 here goes to the normal side. You might be tempted to put the 6 over here, but it's not an endpoint, so you can't. And I have the 2 y coordinates. This is an endpoint, so that's fine over here, but the 1 is the midpoint, so it needs to go on the left. Then I can multiply both sides by 2 to simplify. 12 equals 2 plus x sub 2, and 2 equals 7 plus y sub 2. Subtract 2 from both sides on this one, and subtract 7 from both sides, and we get a midpoint of 10, -5. And again, you could graph these just to make, not a midpoint, I'm sorry, an endpoint of 10, -5. And you can graph these to make sure that it makes sense. Now, distance is another thing we look at in this unit. And my personal favorite is to use the Pythagorean Theorem. It's the simplest, there are less errors in it you can count, but it won't always work. So it should work most of the time. So if you're using Pythagorean Theorem, which is the simplest method, first of all, you're going to make a right triangle by drawing a horizontal line from the first point and a vertical line from the second point so they meet. Secondly, you want to record the leg lengths. These are your A's and your B's. These are the legs. So if I were to go ahead, point a highlighter, the leg lengths here go with these values here. All right? Then we substitute into the Pythagorean Theorem and solve for c to get the distance. Do not forget to take the square root at the end, so you're not solving for c squared, but for c. So here in this problem, we want to use the Pythagorean Theorem to find the distance to the nearest tenth from point D to point E. So the first thing we do, and they've kind of helped us out here already, is they've highlighted the 2 legs of our right triangle. When you have these points on the coordinate plane, it makes it really easy to do a right triangle because the horizontal will be perpendicular to the vertical, and it will connect our 2 endpoints. So I can see both legs, and now I'm going to find out how big they are. I count them, and I find that leg A has a length of 5. Leg B has a length of 9. Notice how I put the numbers kind of in the middle. Do not start counting right very early in the number, otherwise you'll be off. So 1 doesn't start here. This is the first block. So if you wanted to, 1, 2, 3, 4, 5, if you can see how I'm counting. Then here I start 1, 2, 3, 4, 5, 6, 7, 8, 9. Do not start your 1 right at the beginning. It's after the jump. So I'm going to use the Pythagorean Theorem, a squared plus b squared equals c squared, and I substitute in the 2 legs, 5 and 9. 25 plus 81 is c squared. Remember to take the square root right here, and we ask to the nearest tenth. This is called an exact answer when you leave it in the square root format. When we get down here to rounding to a specified place value, that is an approximate answer. So my calculator said 10.2956, etc. And I just highlighted the tenths position and looked to the right, which was the 9, and knew I needed to round up to 10 3/10. The other method we can use to find the distance between 2 points is a distance formula. And in reality, it's really the same thing. It's a Pythagorean theorem. It just uses the points to find the lengths of the two legs. So you've got one leg here. It's going to be the y2 minus the y1. And the second other leg here is a difference in the x coordinates, if you can see that. So I put this in here, and it's already solved. It already took the square root. It really is the same thing as the Pythagorean theorem. So let's go ahead and apply this to the same problem we were looking at before. But first of all, let's go over the steps. When using the distance method, you really want to write down the coordinates for the endpoints and label them. You want to know which one's x1 and y1 and which one is x2 and y2. Substitute the known values into the formula and solve for d. By the way, when I was talking about the endpoints, you can have the very first point on the left be the x1 and then the point on the right be the x2. So, but you don't know if it's going to be higher or lower. So we substitute the known values, second step now, into the formula and solve for d. Remember that a negative value when it's squared is positive. Negative 2 times negative 2 is positive 4. So that's a very important thing to remember when doing the distance formula. I've seen a lot of students go negative 3 squared is negative 9. No, when you have negative times negative, it is positive. So let's look at this particular example. And I'm going to label my points, see how I put x1 and y1 and x2 and y2. And I wrote down my formula. It is always good practice to write down the formula before you substitute. And a lot of times kids will go ahead and actually miscopy the formula. That's why this is a really good step. You want to make sure you're using the right formula. Now I substituted. See how I have x2 here and x2 here, so it's negative 2. Then I have x1 here and x1 here, which is 3. Negative 2 minus 3 squared plus, and then my other points are negative 5 minus 4 squared. Combining the terms there, I get square root of negative 5 squared plus negative 9 squared. Squaring the negatives, remember those are positive. Adding them up, I get 106. This is my exact answer. But since we want it to the nearest tenth, we use the calculator again. And since it's the same as the last problem, I will get 10 3/10. Finally, I'll leave you with a reflection. Could you switch x2 and x1 in that distance formula and y2 and y1 in the distance formula and still get the correct distance? Would it also work for the midpoint formula? Just something to think about. Go ahead and tell me what you think and be prepared to defend your reasoning.